All right, we're looking at question number 2. The graph of the equation y equals 2x squared minus 16x plus 14 intersects the y-axis at point A and the x-axis at points B and C. So what we're actually going for here is graphing points A, B, and C and looking at the triangle that's formed between those 3 points. So let's go ahead and start by graphing this using our graphing calculator, and let's see what we have. Starting at the y equals screen, I've got 2x squared minus 16x plus 14. This is a quadratic function in standard form. My a value is positive 2, which means that my parabola is going to open upwards. My b value is negative 16, and my c value is positive 14. So I can actually look at this standard form equation and know for sure that my y-intercept is going to occur at positive 14. Let's take a look at that graph. And I'm going to trace directly over to those points. Now, when you hit the trace button on your graphing calculator, it will tie your cursor to the actual function. So when you hit your cursor buttons left or right, you'll see that your cursor is kind of stuck on the function. It can't travel outside of the line. Now, I don't want to rely on my trace button to find my x-intercepts directly, so what I'm going to do is directly calculate them. If you hit the second button and choose second trace, that opens the calculation screen. I want to choose option 2, which is the 0. Remember, we're looking for the 0 or the root, which is the same thing as the x-intercept. I'm going to choose option 2 and hit enter. Now, the calculator is going to ask a couple of sort of bizarre questions, but I'll explain what they mean. The first question is asking for a left boundary. In other words, the calculator is saying, okay, what's the furthest value to the left that I need to search to find the x-intercept? Well, what you're going to want to do is position your cursor somewhere to the left of the actual x-intercept. So I see that my x-intercept appears to be right around x equals 1, so I'm going to move my cursor so that it's just to the left of that. I'll hit enter. And then it'll ask a second question. It says, what's the right boundary? In other words, it's saying, where do I stop my search? On the right-hand side. So you're going to position your cursor somewhere to the right of the x-intercept. When you hit enter, you may notice that we've set up little goalposts here. We've got a left-hand boundary and a right-hand boundary, and there's little arrows between them. The reason we're doing this is that there's actually more than one solution, and the calculator needs to know which area of the graph it needs to search to find that solution for you. The last question it asks is a guess, and so it's asking you to place the cursor as close as possible to the actual x-intercept. It's going to start its search there. That way it can kind of quickly calculate what your 0 is. It doesn't technically matter whether your guess is accurate or not, but if you place your cursor near the actual x-intercept, it will calculate it a moment faster. So let's hit enter there, and of course it calculates our 0 as x equals 1, y equals 0. So I'm going to make a note here that my a value is 0, 14, my b value is 1, 0, and I'm going to use the calculator to go for that other 0. So once again, I'm going to hit the second trace button, which is actually the calculation screen. I'm going to choose option 2, 0, and this time I'm going to set up boundaries over here on the other side of the parabola. So I'm going to move my cursor over to the other side of the parabola, and to set up my left boundary, I'm going to just make sure that my cursor is on this side of the 0. So I just want to make sure that my cursor is to the left of that, and hit enter. The right boundary needs to move the cursor over to the right-hand side. Once again, you'll sort of see the goalposts here. We want our 0 to be between those goalposts, and the third question asks for a guess. This is to improve the calculator's speed in calculating the actual x-intercept. I'm going to put my cursor as close as I can to that real 0 and hit enter, and it finds the actual x-intercept is 7, 0. So my final ordered pair is 7, 0. Now, I need to construct a triangle out of these points, and I need to find the area of that triangle. So let's take a moment to do that. Okay, that means that our triangle will have a height of 14 units. When we look at our x-intercepts, which correspond with points B and C, they are spaced 6 units apart from x equals 1 to x equals 7, so the base of our triangle will have a value of 6. To find the area of a triangle, I take 1/2 of the base times the height, and so that will be 1/2 6 times 14, or the same thing as 6 times 7, which is 42 units squared. So the correct answer choice here is choice A.